Okay, so in this video we'll be learning about Python decorators. It's quite an interesting feature in Python. So let's see the problem first, then we'll come to the solution. So if I write a Python function like a function that can actually find the factorial of a number, and if I say def fact n and I say result is equal to 1, and I run a for loop for I in a range 1 to n plus 1, and I say result is equal to result into I. So result into I, and then I return the result. And if I just call this factorial function with n equal to 10, and I store the value in a variable called f, and then I print f, right? I should get the factorial of 10. If I run it, I get 362888800, and you see the factorial of 10 is this same number, so we are good. And now what I want to do is whenever this function is getting triggered, I want to print a log statement, right? So as soon as I enter this function, I will say print the function name, which is fact, is getting triggered, is getting called. Okay, and whenever this function has done its processing, before I return the result, I'll say fact is over. Okay, and now if I just run it, I'm going to get the log print statements. Fact is getting called, fact is over, and then I see the result. Okay, great. The problem arises when I have multiple functions, right? If I have another function, right, which actually finds a sum till n, and I say sum is getting triggered, and over here I say plus, and it is going to start from 0 to n, right? N plus 1, and result is 0, and it is going to get me the sum till n, and I call this as sum. So let's not call it as sum, let's call it as add, and I say add till 10, and I print s. Okay, so if I just try to run it, I'm going to see the result. So first of all, fact is getting called, fact is over, then I see the result, sum is getting called, and I'll change this to sum is over, right? So sum is getting called, sum is over, and I see the sum. Okay, so this is all good. The problem is going to come, the problem is going to get scaled up when I have 100 functions, and in every function I have this log, right? And if tomorrow my manager asks me to change the format of these log statements, I'm fucked up, because I need to go in every function and change the print statements, right? So that's where the decorator concept in Python is super helpful, because by official documentation or official definition, decorators are helpful when you want to change some of the specifications, or you want to modify the function, underlying function, without actually making modifications to the underlying function. Okay, it's a bit tricky, but let me show you. So you define a decorator just like a normal function. Okay, so I say def logger, and I'm going to receive a function. So let's receive a function, and this function, this logger function, is just like a Python function, and inside it I have another function which is called wrapper. Okay, and this wrapper, inside this wrapper, you just call this function. Okay, so I just call this function, right? And what I'm going to do is I store the value of this function in a variable called v. Okay, because you see all of these functions are returning a value. Okay, so I store it in v, and then I just return v. Okay, and this logger function is going to return nothing but this wrapper function. It's a bit tricky, but if you will try to implement it on your own, this will become super simple. So what I did, I called a function. I basically defined a function logger, which is my decorator function. So how I'm going to use this? You can actually call this logger function like you typically do in Python, like this. Like when you are triggering this fact, before this you can actually call logger, and you can pass fact just like this, right? But let's not do it. Let's do it in the way Python suggests us to do. You just use at, or you use annotation. We call this as annotation in Python. You say at logger. Automatically the function which is lying below this decorator, this is called the decorator, and this is called the decorated function. Automatically the function lying below this decorator will be passed to this logger, and inside this logger this wrapper will be called. this function will be called, value will be returned, and this wrapper is returned. Okay. So now what I'm going to do is I'm going to remove these print statements from my actual functions. Okay. I'll remove this, and then I'm going to define logger over here also. This is going to run in the same way. I'm not making any more changes. Okay, I'll run it, and there is a problem. Takes 0 position. Okay, yes. The problem is these functions fact and add requires a parameter n, but over here we are not providing that parameter. So for now I'm going to remove this and hardcode n equal to 10 inside my function itself. And here also I don't need to provide 10. Okay, so I will just save it and let's try to run it, and I am getting my answers 3628800 and 55. Where are my print statements? So those print statements or those log statements I can define over here. So as I've got my function over here, I can say function name, and you can capture the function name like this. You define the function, right, and you say dot name, and now your f name will have your function name. So before calling the function, you can have a print statement which says use the format and you print the function name f name and say f name is getting called. Okay, in the similar way, before you return the value, you can say f name is over. Okay, I don't need to define these print statements in my main functions now. Whenever in the future you want to modify the log formats, you can just make the changes over here and it is going to work without any issues. Now if I just clear it and if I just run it, you see f is getting called, f is over, fact is over, fact is getting called, fact is over, add is getting called, add is over, and then I see the results. Awesome. So like this, you can use the decorator functions in Python. Now the thing that we missed is if you want to pass a parameter, let's say this these functions need n. Okay, I can't always hard code the values of n, right? So I do that and I remove n equal to 10 from here, n equal to 10 from here, and now I need to pass the function variables. So for that I can accept some arguments and I can accept some keyword arguments. Okay, some keyword arguments. Okay, now whichever whatever types or whichever parameters you are passing to the function over here, they will be passed over here, and the same arguments and the keyword arguments which I received in the wrapper function, I'll pass it to this function. Okay, I'll save it, and then if I just run it, you see it is working without any issues. Okay, like this you can pass the variables to your decorator function. And this decorator function is super helpful for logging purposes basically, and some other use cases also. But let's say you want to measure the time taken by this function to get executed. Okay, so I can import time module from Python, and over here, right, I can say time dot time. Okay, and I can say like this, and a similar thing I can do over here. Okay, let's remove this and let's just save it. So this, I can see the time at which this function got triggered, the time at which this function was over. And if I find the difference between these two time, if I just define them as a variable, then I can measure the time taken by this whole function to get executed. And all of this I don't need to do in the actual function. I can use a decorator for that, and I can call it as time logger. Okay, I can call it as time logger. So you can have multiple decorator functions in your code for various purposes. So if I just save it and if I run it and if I see the output, you can see at this timestamp the function is getting called, at this timestamp this function is over, and this is the output. This is the time at which add got called, this is the time at which add got over. Okay, find the difference, you get the seconds, microseconds in which this function got executed. So I hope you enjoyed this concept. Till the next video, keep coding, keep innovating, and thanks a lot.